Most of what your homework tonight is about is a repeat of what last night was. Today, the one difference is that we'll be graphing quadratic equations. What they technically will say is graph the function k defined by the equation y equals k at x, which equals negative x squared plus 2x plus 2. The point here is that this is not just the function here. We're not looking for specific values of the function. We're looking for all of the y's that go with this function rule. So, to do this, the first thing you need to do is find the coordinates of the vertex. As you know from yesterday, x is always equal to the opposite of b over 2a. In this particular function, a is negative 1 and b is 2. So the opposite of b is negative 2, and 2a is also negative 2, so that equals 1. X equals 1. And then to plug that into the equation, or the function, here, I'm going to take all of this and plug in 1. So the opposite of 1 squared plus 2 times 1 plus 2. So that's negative 1 plus 2 plus 2 gives me 3, making the coordinates of my vertex 1, 3. So I'm going to go over here, I'm going to graph this. 1, 2, 3. Okay, from there, what we need to do is find some other points that are easy to do. And you might want to make a little table here of your values. So we already know that when we plugged in 1, 3 came out. As always in the function game, when you plug in 0, that's the easiest thing to do. So 0 squared is 0, 2 times 0 is 0, so when I plug in 0, 2 comes out. Now I know that all parabolas are symmetrical, so if this is a point, then over here the 2, 2 is also a point. We don't even need to do the math for that. So then let's think about what another good number might be. We've already got 1, we've got 0, we've got 2. Let's try negative 1. The opposite of negative 1 squared plus 2 times negative 1 plus 2 is negative 1 minus 2 plus 2. So when I plug in, so this all equals negative 1. When I plug in negative 1 for x, negative 1 comes out for y. So negative 1, negative 1. And I know that if that's 2 points away from the symmetry, line of symmetry, that this is also a point. And if I did the math, I could show you that 1, 2, 3, negative 1 will also be a point. Now that I have these 5 points, I'm going to erase this one because it makes it hard to understand. I then sketch as nicely as I can, and that's not so nice, but you get the idea that this is a parabola with this point, 1, 3 as the vertex. It opens downward because A is negative, and its axis of symmetry is x equals 3, and x equals 1, and it has a maximum or greatest value of 3. That's the highest point in the parabola. So let's just try to put these steps in isolation. Is find and graph the coordinates of the vertex. Okay. From there, choose easy numbers as x, easy numbers, meaning like 0, 1, -1, and plug in to find their y. The corresponding y. You might want to make a table of values at this point. Remember to use the points of symmetry. Okay? When you have 5 points, whoops, I was saying 5 and so I wrote 5. When you have 5 points, when 5 points are graphed, sketch the parabola. Okay, let's do another example. I'm just going to do it. I'm not going to worry about not going to worry about the steps. So here we have h at x is represented by 2x squared plus 4x minus 3. Before I do anything, I can see that this is a smiler, and so it's going to have a least value, and from there we will figure out how to graph other things, beginning with the vertex. We can see that A is 2 and B is 4. So the opposite of B over 2A is equal to -1. When I plug -1 into that function to find out what the y that goes with that is, in other words, h at -1 is 2 times -1 squared plus 4 times -1 minus 3. So that's positive 1 times 2 is 2 minus 4 minus 3, and that gives me -5. So the coordinates of the vertex are -1, -5. And I might want to put that in my little value here, -1, -5. -1, 1, 2, 3, 4, 5. Okay, it's going to open up. So let's try plugging in +1. What happens when I plug in +1? 2 times 1 squared plus 4 times 1 minus 3. So this is 2 plus 4 minus 3. 6 minus 3 is 3. So when I put in +1, +3 comes out. That point is here. 1, 1, 2, 3. Because this is where my axis of symmetry is, if this is 2 points away, I can also use this symmetrical point here. That's 2 points away from what will be my axis of symmetry. If I could draw a little better. Okay, I'm thinking that 0 would be a good one to put in, because 2 times 0 squared plus 4 times 0 is already 0. So minus 3 is -3. So I've got 0 and -3. Also, the point that I didn't do the math for was -1, 2, 3. We had -3 and +3. So 0 and -3 is here, and the symmetrical point is over here. So I now have 5 points. I can do my best to draw a nice little parabola. This one is skinnier, by the way, and that's because it's being multiplied by 2. The quadratic term, the bigger that is, the skinnier things get. And so this is how we graph it. I can say that it has a least value, or lowest point. The lowest y anywhere is -5. And the equation for the axis of symmetry is x equals -1. So I think that should be enough to get you through these. That's 2 examples, and it's really the only hard part at all is just plugging in the numbers for the math.